Hello, everyone. My name is Richard Matic. I'm a doctoral student in experimental psychology, and I'm presenting on some research that I'm doing in sentiment analysis. The project is actually part of a larger research project that I'm working on that I want to briefly explain to you. I'm working on a model of marital satisfaction that was created by a psychologist named John Gottman in the 1990s. And what the model essentially shows, and I'm going to share my screen over here, is that couples, this was John Gottman, by the way, and this was a famous book that he wrote called The Mathematics of Marriage. And that is the book that I'm basing this research that I'm doing on. What John Gottman discovered was that there were two types of relationships in marriage. And this came out of, partly out of an impetus in Professor Gottman's own life after having been divorced twice. He wanted to find out what made some couples stay married and have satisfying relationships, and what made some couples have end in divorce. So if you track a conversation of a couple speaking about a current problem in their relationship, you find two patterns, which are shown here. One is that the sentiment of the conversation progressively improves at each turn of the conversation. And that type of pattern is characteristic of what Gottman called low-risk couples that have higher satisfaction and are likely to survive as a couple. High-risk couples, on the other hand, at every turn of the conversation, have progressively lower and lower sentiment scores for what they're saying. So my research has the purpose of trying to computerize what John Gottman actually did in the 1990s using human judges to evaluate recorded video conversations between actual couples in his lab in Washington University. So what I have done is to first try to find some natural language processing tools that would be useful in analyzing conversations between couples, otherwise known as dyadic conversations. And I started out with what we already know from our course, which was text blob. So I have a program in Colab that uses text blob to analyze actual conversation. And where did I get the conversation? There are some data sets available publicly of actual conversations with a ground truth established by a group of human judges actually evaluating the sentiment of each turn of the conversation. So if you look at this chart that I created over here, you have a conversation, the person speaking, either A or B, and then they have a score that the human judges evaluated each turn of the conversation or each line for. And what I did is I took that human generated score as ground truth and compared it to what text blob produced. So here, TB is text blob. You get a polarity score. And then I just converted that into a assigned integer, either 0, -1, or 1. And that represents the sentiment value. And then I compared it to what the human judge actually had there. In this column, if there's an X, the computer got it wrong. So there's a number of X's in this column, as you can see. So text blob is not perfect. For example, I'm still holding the ladder, you know. That was evaluated as a negative sentiment, which indeed it should be in most cases. But text blob put it at 0. In other words, just an objective piece of information, which it is also a piece of information, but you know, without maybe more experience in English, you wouldn't know that. It probably means, hey, I got a problem here. So it should be negative. So text blob got it wrong. The next thing I did was, you know, I assume, you know, text blob is open source, must not be that good. Let me go with Google. And I used Google's language API, Google Cloud Language API, which is available for a charge. And I did a trial run of it for free. But unlike most of the Google products I know, it turned out to not be as accurate as the open source text blob. So you could see over here, this is the score in Google language, and here's the number incorrect. They actually got more incorrect, even though this is a paid platform, which is kind of interesting. I calculated overall accuracies. This is not definitive because I had to abbreviate the data set because the Google API did not allow me to utilize the 30,000 API calls that I needed. But just with the ones that I did in the test set, I had, let me see here. Somewhere. All right, well, that's a shortcoming on my part. It disappeared. But this was somewhere in the area of 46% correct, while text blob was in the upper 50-something% correct. So the field of sentiment analysis is just beginning to have success. I found out with conversational documents, with conversation and people talking to each other, because you're using shorter lines and basically because each person influences the sentiment of the other person. But they are beginning to do some work in this area, and I don't know if they will actually have something that I can use and apply to Gottman's model, or if I will have to try to create something myself, which will be more difficult. The next idea that I had was to try something that I've already tried in another part of my research, which was to actually use a recurrent neural network for sentiment analysis, except this recurrent neural network was created to evaluate the emotional content of tweets. And it generates a set of 5 or 6 emotional states for a tweet, and grades or produces a score for each emotion. So I thought to take those emotion scores and convert them into sentiment. So for example, you have anger, sadness, happiness, surprise, disgust. So some of them are negative, like anger, sadness, disgust, and some of them are positive, like joy, happiness, and maybe something else there. But that would be a basis for making a conversion. So that's actually the next project that I'm doing, and I would like to hand in for this class for natural language processing assignment number 3, which is the last assignment. Basically took too many classes this semester and ran out of time to get this stuff done. in a reasonable amount of time. So trying to get everything done now. If it is successful though, and this research actually produces a reasonably accurate method of recording sentiment of conversations, I can then use that to connect with the Gottman model. And this is an example of the Gottman model. This is a small program that I wrote in a sketchbook app called Processing, which is used for graphical simulation. And it's written in kind of based on Java, which I never used until this class. So I'm glad I actually had a chance to use it. But if you take Gottman's model and run it in this, what you get is colors representing the wife and the husband in the relationship. And as you could see, I'll run it again, but as you could see, as the model runs through the iterations, the colors get progressively darker. And in fact, the mood gets progressively darker. And you can see that in this plot over here. Husband and wife decline in their mood and their love for each other, and reach a steady state in this model that is representative of Gottman's chart over here for the high-risk couple. And in fact, this model uses the same parameters that Gottman derived from his analysis of sentiment of conversation, and then plugged them in to his mathematical system of equations to predict the future happiness of the couple. If I can do this, we can actually get something online where a couple can come and record a brief conversation of them discussing a problem in their marriage and give them an assessment of the future prospects of their relationship, or say it's just two people considering marriage. You know, you can give them a prediction for how successful the relationship is going to be, and possibly you could provide feedback like a good marriage and family therapist would do to try to help them in their relationship and in their choice of spouse. So that's the goal with all of this. And if it works, you know, stepping out a little beyond natural language processing, you could actually add the content of the voice, which is called the voice prosody as well. So that's called multimodal analysis or recognition of emotion and sentiment. So you're using the lexical content, the grammar and so forth, as we have in this class, but you're also using the sound, the intonation, the pauses, the speed, the loudness of the voice. And you combine them both together, you can approach the accuracy of human judges in evaluating the sentiment of two people in a conversation. So that's the goal. I thank you for listening, and look forward to handing in assignment 3 very soon. Thank you.